Hey guys, this is test 66 game 1. This is the lab sessions game. It's an ordering game. We know this because we have the days of the week Wednesday, Thursday, and Friday, which we are placing in order with the labs, and we have morning and afternoon as well. We know that K and R have to be on the same day, although we don't know who's in the morning, who's in the afternoon. We know L and O cannot be in the same day. We know that N is in the afternoon. And we know that J is before O. So on this basis, we can infer that O is never Wednesday and J is never Friday, since J goes on a day before the day on which O goes. Now, because we know that O and L cannot go together, and that J is before O, and that K and R are on the same day, we can make an inference. O cannot be with J on the same day, O cannot be with L, and O cannot be with either K or R because they're together. As such, we can infer that O and N must be together. And since J is before O, J goes on an earlier day than O and N go on. So for this reason, we can make a few different diagrams based upon the placement of O and N. Since J goes before them, we know that O and N will go on either Thursday or Friday. So I'm going to make two different diagrams representing those different possibilities. So we can have O and N on Thursday, or we can have O and N on Friday. Now, if O and N are on Thursday, we know J is going before them, so we're going to have J and L interchangeable on Wednesday. Of course, since J is not going with K or R, and it can't go with O or N, it has to go with L. So J and L interchangeable on Wednesday versus J and L interchangeable on Wednesday or Thursday in the bottom possibility. So we don't know whether we're having J and L on Wednesday and K and R on Thursday, or vice versa. So I actually split this into two different possibilities here based upon the placement of K and R. We could have K and R on Wednesday, or we can have K and R on Thursday. So I'm going to lay those out now. And of course, wherever we're not having J and L, we're going to have K and R. So those are our three different main possibilities for the game, and they'll carry us through the questions, making them much easier to solve. So we start with question number 1, a typical orientation question, where we'll just take one rule at a time and apply that rule to all 5 choices, looking for violations. While our diagrams here will be useful for the later questions, this question we should solve simply with the initial rules. So for example, we know that J always goes on a day earlier than the day upon which O goes. So for that reason, we can eliminate B, which has O going before J, unacceptable, so that's gone. We know that O and L are never together, so for that reason, we can eliminate D, which lists O and L going on the exact same day. We know that N's always in the afternoon, so for that reason, A is gone. And we know that K and R always have to be on the same day, so for that reason, C is gone, leaving E by elimination for number 1. Next, number 2, if L does not lead a Wednesday session, what must be true? So looking at our 3 diagrams here, we have, L on Wednesday in both the top diagram and the bottom one, so the middle one's the only one that's relevant right now. And we see that when L does not lead Wednesday, we have J going on Thursday as well as L. Of course, L's not a choice, but J is, so E is our answer for 2. Next, number 3, if K goes the day before N. So if K goes immediately before N, on the day immediately before that, top diagrams are relevant since K is after N. Middle diagrams are relevant because there's a day in between them, so the bottom one's the only one that matters. And we see that Thursday can only be K and R, and no one else, so for that reason, B is our answer to 3. Next, number 4, if J and K both led morning sessions. So this, of course, could happen in any of our 3 diagrams, but I'll limit them further to be specifically what the question stem is saying here. So J and K are in the morning. That means we're going to have L and R in the afternoon for each of these. So I'm just going to cross off what's not happening to leave us with what is happening. In the bottom diagram, of course, J and K both in the morning means R and L both going to the afternoon. So now they're asking us, could be true except. Could we have L going on Wednesday morning? That happens in none of these because L was forced into the afternoon, so A is impossible, and as a result is actually our answer for number 4. Next, number 5, if J leads the Thursday afternoon session. So if J is Thursday afternoon, the top possibilities are relevant. The bottom possibilities are relevant because J certainly couldn't be on Thursday at all there. Only the middle possibility is relevant, where I'm specifically putting J Thursday afternoon, so L is forced into Thursday morning. And they're asking us, how many other sessions can we determine? Well, aside from J, we know about L, O, and N specifically. So besides J, we have 3 others. So for that reason, choice C is our answer to 5. K and R are, of course, still ambiguous.